All right, what if your AI assistant could act less like a script follower and more like a really skilled programmer? Today, we're going to dig into a huge shift in how AI agents work, a change that makes them way faster, cheaper, and a whole lot more powerful, just by teaching them how to code. So, here's the plan. We're going to start with the big vision of a totally connected AI world, and then we'll shine a light on the huge bottleneck that's been holding everything back. After that, we'll get into the really cool part, an elegant solution, break down all the surprising perks, and wrap it all up with the key things you really need to remember.
Okay, so let's jump right in. To really get this, we first have to understand the foundation of how these AI agents connect to the outside world. And that all comes down to a protocol called MCP.
So, the Model Context Protocol, or MCP, just think of it like a universal travel adapter, but for AI. It's a standard that lets any AI agent plug into pretty much any tool out there, your Google Drive, Salesforce, you name it, without needing a custom connector for every single one. It's all about universal compatibility.
And the goal here is, well, it's massive. We're talking about an AI that can seamlessly tap into thousands of different tools and services. This isn't just about making things a little easier. It's about building agents that are truly powerful and can handle really complex real-world tasks. This is how we unlock what they can really do.
But there's a pretty big roadblock. You see, as we start plugging in more and more tools, a serious bottleneck starts to show up. It's kind of like a traffic jam inside the agent's short-term memory, which we call its context window. Just picture it like a tiny notepad. If you scribble too much on it, it gets cluttered and the agent can't think straight. You see, the way we do things now, by directly calling each tool, creates two huge problems. First, the instruction manuals for all the tools, the tool definitions, they just overload the agent's memory. And then the results from every single little step, well, that creates even more clutter. What you're left with is a process that's super slow and way more expensive than it should be.
And this is the crazy part. Imagine that before you even ask your assistant to do something, it has to read an entire library of user manuals. That's basically what's happening with these tool definitions. Then, let's say it goes and gets a meeting transcript. It has to read the whole thing to understand it, and then read it all over again to pass it to the next tool. It's just incredibly wasteful.
So, how in the world do we fix this giant mess? Well, the solution is actually pretty brilliant. Instead of making the agent call all these tools one by one, we let it do what large language models are amazing at. We let it write code. Just think about that for a second. This one simple shift completely changes how the agent works. It goes from this clunky, step-by-step process to something that's way more fluid and efficient. You know, kind of like how a human programmer would actually solve the problem. So here's what that new, smarter workflow looks like. The agent basically acts like a developer. First, it just looks at a list of available tools, like Google Drive or Salesforce. Then, it only reads the instructions for the one specific function it needs, like get a document. And finally, it writes a quick little script to get the job done and just runs it. Simple.
And the result of this change? Honestly, it's staggering. For one sample task, this new method cut down on token usage, time, and the total cost by 98.7%. A job that used to chew through 150,000 tokens now only needs about 2,000. That's a total game changer. But okay, saving a ton of money and time is awesome, but the benefits here go way beyond just that. This new approach really upgrades what an AI agent can even do in the first place. Okay, first off, with progressive disclosure, the agent only loads the exact tool it needs right when it needs it. Super efficient. Second, it can sift through huge amounts of data on its own and only pass the important, summarized bits back to its brain. And finally, it gets the power of real programming logic. Using things like loops and if-then conditions. And this right here really drives the point home. With the old method, the AI model would have to read all 10,000 rows from a spreadsheet. Just all of it. With code execution, the agent writes a little script to find what's important and only passes the 5 most relevant rows back to the model. Massive difference. This also unlocks some huge benefits for privacy and security. Really sensitive data can be processed without the AI model itself ever having to see it. The agents can also save their work to a file and pick it up later. And what I think is the most exciting part, they can save the code they write as new, reusable skills. They can actually learn and get better over time. So let's wrap this all up and look at the big picture. This method is incredibly powerful, but like with any really advanced tech, there are some important trade-offs you have to think about. So on one hand, yeah, the old way with direct tool calls is simpler to set up and it's fine for basic tasks. But for anything complex, code execution is the clear winner. Now, it's not a free lunch. Letting an AI run code means you absolutely need a secure, sandboxed environment to keep things safe. So there's a bit more setup and security planning involved up front. So if there's one thing to take away from all this, it's this: that limited working memory, the context window, is the biggest thing holding back more powerful AI. The solution is code execution, which basically turns the agent into a little software developer. This shift doesn't just slash costs by almost 99%. It unlocks totally new abilities, making agents more powerful, more private, and able to learn. And what's so cool is that this isn't some crazy new idea. It's just applying smart, proven software engineering principles to solve the next big challenge in AI. Hey, if you found this breakdown helpful and you want more deep dives just like it, do our friendly neighborhood algorithm a little favor. I'm told it gets a tiny dopamine hit every time someone subscribes to VibeDoc. So, do it for the AI. Go on and hit subscribe. And that leaves us with one last thing to think about. We've just taught our AI agents how to write their own code to solve problems. As they start to build and save these new skills for themselves, what incredible new things will they teach themselves to do tomorrow?